Here we see a rock covered in strange, dark spots. On Earth, patterns like this nearly always trace back to living organisms, microbes that left their mark in the mud. But this rock wasn't found on Earth at all. It's on Mars, in Jezero Crater. In a recent announcement, NASA scientists revealed that this Martian rock may hold the best evidence yet of ancient life on Mars. Those peculiar spots and circles on the rock, nicknamed leopard spots and poppy seeds, have set off excitement around the world. Could we finally be seeing signs that life once existed beyond Earth? Let's investigate what Perseverance found and why experts are buzzing that we can't find another explanation besides life. Our story begins in Jezero Crater, a 45-kilometer-wide basin that was home to a lake on Mars billions of years ago. NASA sent the Perseverance rover here in 2021 precisely because Jezero's geology screams habitable environment. Long ago, river channels spilled into this crater, creating a lake and a delta rich in water and minerals needed for life. Fast forward to today, Mars is cold and dry, but fossils of past life, if they ever arose, could still be preserved in the ancient lake mud that turned to stone. So Perseverance has been roving the crater, drilling into rocks and examining sediments, all in the quest to find signs of ancient life. In July 2024, while exploring a formation of layered clay-rich rocks along an old riverbed, the rover's team spotted something odd. A slab of rock stood out, whittled with tiny dark splotches arranged in rings. The team jokingly dubbed them leopard spots for their modeled book. To geologists, this was a potential jackpot. On Earth, similar mineral patterns and lake-bed rocks can be microbial fossil signatures, formed by communities of microbes interacting with sediments. If we saw these spots on Earth, we'd immediately think biology was behind it, one scientist noted. Seeing them on Mars, everyone got excited. Could it really be that Martian microbes left these imprints eons ago? Perseverance drove over to investigate this rock, and the results made the science team's hearts skip a beat. The dark spots contained organic molecules, the building blocks of life, along with an unusual mix of elements like sulfur, phosphorus, carbon, and iron. Even more intriguingly, the instruments found two minerals in the spots that seemed out of place for plain geology: vivianite and greigite. Vivianite, an iron phosphate, and greigite, an iron sulfide, aren't really household names, but they are telltale clues. On Earth, you can find vivianite in muds and bogs around decaying organic matter, such as bones or plant debris, slowly turning blue as it forms. Greigite is an iron mineral sometimes produced by a certain bacteria as a metabolic byproduct. Finding both of these together in patterned halos within a once wet Martian rock lit up the astrobiology radar. The spots appear to be reaction fronts, places where organic matter in the mud interacted with minerals, sparking electron exchanges. On our planet, microbes and oxygen-poor muds often survive by doing exactly that, munching on organics and minerals, and in the process, precipitating minerals like vivianite and greigite as waste. As Perseverance's lead scientist Dr. Joel Horowitz explained, on Earth, reactions like these, combining organic matter with iron compounds in mud, are often driven by the activity of microbes. The microbes consume the organic matter and produce new minerals as a byproduct of their metabolism. In other words, those Martian leopard spots might literally be microbe poop turned to stone. This rock records all three key ingredients for life in one place. It formed in liquid water, the ancient lake. It contains organic molecules, and it preserved an energy source that life could have exploited. That trifecta has never before been found so clearly on Mars in a single sample. So no wonder NASA's acting administrator, upon reviewing a year's worth of data, said that we can't find another explanation. This very well could be the clearest sign of life we've ever found on Mars. It's high praise and a very momentous claim. Now, before we start declaring aliens have been found, let's take a dose of caution. History has taught us that the search for life is full of false alarms. Back in 1976, NASA's Viking landers became the first missions to run life detection experiments on Mars. One Viking test makes nutrients into Martian soil to see if anything would metabolize them. Astonishingly, the soil did release bursts of gas at first glance, exactly what active microbes would do. For a brief, thrilling moment, some scientists thought Viking had detected Martian life. However, further analysis deflated that excitement. The consensus was that reactive chemicals in Mars's soil were tricking us, producing Viking's gases without any biology needed. Mars's soil turned out to be harsh and oxidizing, and Viking ultimately found no organic molecules at all back then. In hindsight, the Viking saga became a lesson. Ambiguous results can mislead us, and non-living chemistry can masquerade as life. Another famous case came in 1996, when a Martian meteorite known as ALH 84001 made headlines worldwide. In that rock, scientists spotted tiny structures under the microscope that looked like fossil microbes, and they even found organic molecules and mineral patterns that hinted at biology. It was enough for NASA to announce possible evidence of ancient Martian life and prompting the US president to give a speech about it. Yet, over the following years, skeptics showed that those micro-scale features could be explained by inorganic processes. Once again, what seemed like a breakthrough turned into an unsolved puzzle, with most experts now agreeing that the meteorite did not contain proof of life. So what makes the Perseverance discovery different? In a word, context. We now have a rock taken directly from Mars's surface with a clear geologic story and multiple lines of data all pointing to life's handiwork. The sample comes from fine-grained, clay-rich mudstone, exactly the kind of material that's great at preserving microscopic life on Earth. This mudstone formed when water was present and soaking the sediments. Perseverance instruments detected organic carbon in it, as well as the elements sulfur, phosphorus, hydrogen, and oxygen in key locations. These elements weren't just randomly scattered. They were concentrated right where the mysterious dark spots and veins are. It's as if the rock has a chemical bullseye painted on it, and that bullseye is screaming, "Life was here." Importantly, the Perseverance science team spent a full year analyzing this data and trying to think of every possible non-biological explanation. By September 2025, they reported that no purely chemical explanation fits all of the observations. As one NASA scientist said, "We put it out to our scientific friends to pressure test it, and they all came back and said, 'Listen, we can't find another explanation. Life checks all the boxes here, and as of now, nothing else does, at least not convincingly.'" Let's play devil's advocate for a second. Scientists considered a few alternative hypotheses and investigated each one for how these intriguing features could have formed without life. The first of these is high-temperature geochemistry. Could heat and water alone, deep underground, have formed the vivianite and greigite spots? Possibly, but the rock shows no signs of being baked by high heat. In fact, vivianite specifically forms at low temperatures and would have been destroyed if the rock had ever been significantly heated, so a hot hydrothermal origin is very unlikely. Maybe acidic fluids percolated through the rock for ages, creating those minerals. Mars had acidic groundwater in some places. However, if strong acid had flowed here, we'd expect to see other hallmarks. Certain alteration minerals, widespread corrosion of the rock, etc. Perseverance didn't see those. Instead, it even found olivine, a mineral in the rock's veins, and olivine gets eaten away by acid. So the presence of this olivine pretty much rules out a long acid bath. Maybe the organic molecules themselves somehow catalyze the formation of vivianite and greigite without life. For instance, in the presence of a special metal catalyst. This scenario was harder to dismiss outright, but at the low temperatures indicated, there's no evidence of a chemical catalyst doing the job. It would require a very specific and coincidental set of conditions that scientists find improbable given what we know. So after weighing all of these, the researchers agreed that ancient microbial life is the best explanation for the leopard spot features. The data perfectly line up with what we'd expect if tiny Martian microbes once lived in that lake bud, used minerals like iron and sulfur for energy, and left behind these mineral fingerprints as a waste product. It's a scenario astrobiologists have speculated about for years, now suddenly supported by real evidence in hand. Mars might not have only been habitable in its distant past, it might have actually been inhabited, at least by simple life forms. Still, NASA hasn't declared we found life, so why the hesitation if no other explanation fits? Right now, it comes down to scientific rigor and the need for absolute proof. In science, extraordinary claims require extraordinary evidence, a mantra often attributed to Carl Sagan. Finding life on Mars is just about as extraordinary as it gets. NASA knows that the world and other scientists will demand an extremely high standard of proof for such a claim. Right now, what Perseverance found is officially termed a potential biosignature, which means it might be biological at origin, but obviously we don't have 100% certainty just yet. The rover's instruments, as advanced as they are, have limitations. They can identify interesting chemicals and minerals and suggest processes, but they cannot directly see microbes or their cells. We're interpreting indirect clues, which is always subject to revision if new data comes along. To guide these situations, NASA scientists use something called the confidence of life detection scale. It's a 1 to 7 scale where level 1 is a hint of something that could be life, and level 7 is essentially confirmed life with multiple independent lines of evidence. Right now, this finding sits in the middle of that scale. A strong hint, but not a confirmation. The rover has pushed the data as far as it can go while on Mars. NASA also remembers its past embarrassments, like Viking and the Mars meteorite, and is therefore very careful with wording. Associate Administrator Dr. Mickey Fox clarified in the press briefing that it's not life itself that they found, only signs that could be from life. They won't say, "We found life on Mars," until there is no shadow of a doubt. This cautious approach is important to maintain scientific credibility. After all, some extraordinary evidence might be just around the corner, but we need one more step to get there, which is bringing the sample back to Earth. In the coming years, all eyes will be on that little metal tube inside Perseverance labeled Sapphire Canyon. It holds answers to questions humans have asked for millennia. Did life ever exist on Mars? We now have the strongest hint so far that it did. The scientific community is buzzing, consciously optimistic but hungry for more proof. If all goes well, a decade from now we'll be poring over Martian rock samples in our laboratories, and perhaps finally greeting the evidence of a long-dead Martian microbe, a discovery that will echo throughout history. For now, we have a tantalizing clue carved in Martian stone, a leopard-spotted rock that whispers of possible life. Humanity stands at the edge of knowing something incredible. Mars may have once been alive. If that's true, the universe suddenly feels a lot less lonely.